Greetings, my name is Don Mabey, and I am the Director of Marketing for the Qwickinstall frame system. The information in this presentation is focused on the lean construction concept of analyzing and improving value-added activities. Every construction project has two common components, walls and door openings. Both components are so common that we tend to take them for granted. When this happens, it is easy to assume there is nothing new in the construction process that will have an impact on improving quality, efficiency, and productivity at the work site. You are about to be a part of a video Gemba Walk experience to help you understand the effect of variation on the process of installing drywall behind welded hollow metal frames. Because of your association with the Lean Construction Institute and past attendance at one or more LCI congresses, you most likely are familiar with the term Gemba or Gemba Walk. The Lean Six Sigma definition shown here states the word Gemba refers to the place where the value is created. The silhouette image depicts a high value-added activity. When you drive a screw to join two components together, you have added value to the assembly. Although Gemba is a singular word, it becomes an action when the words go to are added. It describes actually going to the place where the work is done. When we were in school, we called that a field trip. But in our professional activities, do we really understand what this means or what to do when we get there? And once we return from Gemba, what do we do with the information we learn? Although Gemba is a word, as shown here, it can be used as an acronym to help us understand what we do during a Gemba experience. The purpose of a Gemba Walk is to involve everyone touching the process to understand how value is added and waste is generated today. With that understanding, improvements are possible. By involving everyone, changes for implementing improvements are more likely to succeed. Most Gemba Walks turn into a high school field trip. Everyone sees the Gemba through their eyes from their own perspective and preconceptions of what is interesting to each individual. Typically, no data is collected. No comparisons are conducted. Problems are not clearly defined or understood. No root cause is identified. And finally, because this is a group of individuals who each have a small part to play in the process being observed, there is no leader who will take charge and drive the experience to make a change or initiate an improvement. In the end, very little or possibly nothing actually changes, leaving the person actually experiencing the process to be told to accept that this is the way we have always done it. Nobody knows how to make a change. Unless there is a special cause that will delay a project or force a design change, the contractor says, we can't change something, the architect makes changes. The architect says, the contractor needs to request a change before it's too late. And the carpenter, who is actually doing the work to add value, says, I wish someone would listen to me. If you attended the 2018 LCI Congress in Anaheim, California, you probably received a free copy of the book shown here titled The Pocket Sensei. On page 97 of the book was kata number 21, titled Before Anything Else, Give It a Try. The information you will learn about today was gathered when Barton Mallow Construction decided to participate in a lean experiment inspired by the statement, before anything else, give it a try. That lean experiment is the video Gemba Walk you will participate in today. The experiment was set up to understand and compare the interdependence of two related construction processes, drywall installation and installing welded hollow metal frames. The basic process variation being tested is comparing installing the welded hollow metal frames when the wall is constructed versus installing the Qwickinstall frame after the drywall has been installed. An unexpected discovery during the experiment was the significant negative impact caused by a variation in the component used to attach the traditional welded hollow metal frame to the wall studs. This one seemingly minor feature on the traditional frame drove waste and defects into the process. However, who really cares what anchor system is specified or used? The architect knows what to specify, right? The anchor used for the experiment is completely approved and accepted by architects, and in some design situations is the only acceptable solution for attaching the frame to the studs. Briefly, if you are building with wood studs, this is the only method for attaching the welded hollow metal frame to the structure. However, there are steel stud walls designed with tight clearances that will not allow the carpenter to attach to the anchor through the back of the stud. In those situations, this type of strap is the only alternative. The straps used in this experiment had the anchor straps welded in place instead of allowing the carpenter to install the best anchor plate during the installation process. One rather insignificant variation became the root cause of what can only be described as a train wreck for the carpenters participating in the experiment. Because the experiment was video recorded, you now will have the benefit of learning from the experiment as we share the images and results of the value-added work comparison for installing drywall. Although the installation of the frames was also recorded and data was collected, this GoToGemba video experience will only analyze the drywall installation process. The video is recorded in a time-lapse format. Therefore, the action is very quick, and you may end up missing some important parts of the carpenter's value-added work and wasted activities. In your lean training, you have probably been introduced to the 8 wastes of lean shown here. These wastes have been arranged to create an easily understood acronym, downtime. These specific wastes I want you to be aware of as you view the video. Defects, motion, and extra processing. Specifically, here are the actions you will readily observe during the video. Under defects, watch for shaving the edge of the drywall. Also, prying the frame with hammers, and excess scrap being generated. Under motion, too much ladder climbing, excessive measuring, process sequence variation, too much kneeling. And under extra processing, extra seams to fill, excessive cutting, pounding the sheet to push behind the frame, kicking the sheet to push behind the frame, pounding the sheet and crushing the material. Because you saw this as a video rather than during a Gemba walk, we can now share what we learned, and the analysis can be reviewed over and over again to understand the process and consider improvements. We learned the process for installing drywall behind a welded hollow metal frame is inconsistent. There was significant variation in the results for different wall sections. Because of extra cutting and piecing together small sections, the drywall finishing process will be more difficult and time-consuming. The installation process damaged the drywall sheets, which must be repaired by another person, which is adding even more waste to the process. Take another look at this list you saw before the video. Did you observe each of the activities listed? There were probably a few more you can think of if you took the time to view it again. If there is one principle you can take with you today, it is variation works against lean construction principles. It increases complexity and risk while reducing accuracy for predicting outcomes, which directly relates to calculating costs for the project. But why should this happen with the process for installing drywall? Drywall is not complex. The material comes in a few sizes, and the process uses standard fasteners. This should not be difficult. The problem surfaces when door openings are a part of the wall structure. This introduces variation, which is inherent in the design process. As the number of openings increase, the complexity of the process increases. So how can variation associated with door openings be eliminated from the drywall installation process? The answer is to install drywall as full sheets with minimal cutting, as if the wall did not have a door opening. Once the sheet is installed, cut out the opening using the studs as a cutting fixture without any measuring. Scheduling becomes extremely flexible when the Qwickinstall frame is used. This is because the Qwickinstall frame can be installed anytime after drywall is completed. Therefore, install the drywall first without the frame in place. This video Gemba walk you will see is the second half of the lean experiment, where the drywall is installed before the frame. The difference will be striking to you. Here are the results of what you just watched. The process is simplified. The workflow was balanced and improved by the carpenters doing the job. There was no processing damage. There was less scrap, and there was significantly less work needed to finish the seams in the wall. Here is a visual summary of the data and photographs of the results of the two comparisons side by side. What more justification do you need to change the sequence for installing frames so they are installed after the drywall is installed? The solution is Qwickinstall frames. Scheduling flexibility improves on-time construction performance. There is no variation in the Qwickinstall frame process. The frames are always installed after the drywall, and they are always installed using the same process. One man following 6 steps in 6 minutes. Done. Thank you for your attention and interest. Please feel free to contact me directly if you would like to learn more about Qwickinstall. If you would like to keep on learning by having your company conduct your own lean experiment to gather your own data, please call me and I will help you get it done. If you would like to try out a Qwickinstall frame at your facility, please call. As you continue on your lean journey, don't forget the encouragement offered by Dr. Tariq Abdelhamid at the end of every email he sends. Keep on learning.